Yeah. So, and I think in the last three talks, it has been mostly like technical talks, talking about um, pre-training, talking about fine-tuning, etc. This time, I'm talking a little more about the business impact and how, when you are taking things from prototype to production, like what are the things that actually matter. So, just a little about me. So, I am a co-founder of a ML startup, and we have been, you know, we have had language models in production for the last 3 years. Um, so far, we have been using our own models. Um, what I mean by our own models is open source models that we continue pre-training on our own domain, um, on around billions of tokens of financial text. So we are a fintech company. Um, so with that in mind, I guess we also, once GPT-4 came in, we also started using it, and we have launched a couple of products that use GPT-4, and they are in production right now. So I want to take you through my experience working with the LLMs as opposed to the smaller custom models that we have. And by smaller models, I let's like see what constitutes small and what constitutes large. Large is, I would say, anything that is GPT-4 level, or maybe above, let's say, 40 billion parameters, or anything about. Uh, you need multiple GPUs to do inference, even if you do 4-bit quantization, etc. Um, For small, I think the largest small model we use is 20 billion. I think that's probably where the boundary shifts. Uh, you can also think of it in terms of having those so-called emergent properties, which are exhibited by only the much larger language models. Yeah, so I'll talk to you through my experience of how we basically uh, started using the larger models and the pitfalls we encountered and how we kind of resolved them. I'm also writing a book on large language models with O'Reilly, and product design is one of the chapters in it. So I'm writing chapters on fine tuning, data augmentation, how to pre-train, how to domain adapt stuff, how to get rid of you know uh, issues like inference optimization, hallucination, bias and fairness issues, etc. But product design is something that is still kind of underexplored and also underrated. The way the LLMs fit into your entire ecosystem is something that needs to be carefully thought out. And I'll talk about a few of those things today. Um, so, um, Here is something that I see, like talking to a lot of people. I see there's a lot of pressure, especially if you are at like a slightly bigger company. There is a lot of pressure from upper management. Hey, there are LLMs. Do something cool with it. And and I find that to be counterproductive. You have a cool LLM, and this is not even an LLM that you built in-house. It is something that's available out there, and they are telling you what problems can you solve with it. So you are searching for problems that you can solve, rather than already starting with the premise, hey, we have talked to a lot of customers. We know what problems they have, and we were probably already thinking of solving them in different ways. But now let's see how LLMs can help solve it. Um, of course, if you are like a team with a research lab that has developed something new, then the first paradigm, there is a little bit of place for that, because you have something that no one else has. How do you maximize your IP? But overall, I guess, starting from the customer, uh, a lot of companies that are getting into the hype and just trying to have generative AIs anywhere in their product base are missing out on not doing the actual hard work of getting the understanding what problems need to be solved in the first place. So I'm going to take a case study of summarization, and summarization is a very interesting task because I think people were calling this a solved problem in NLP even before like ChatGPT came out. Even like when they were looking at things from BART, especially if you look at the BART paper, that's got some really cool summarization tidbits. Of course, it looks cherry picked and everything, but a lot of people were calling summarization a solved task in 2021, and it even there are companies today, like for example, there are LLM companies today that offer a summarization endpoint where you can just summarize by calling an API call and giving it text. And is that really the case? Is that as simple as that? Is there really nothing, no business value to be captured by summarizing something just because it's already something that you can do with ChatGPT? And we'll talk about that. So one thing, so let's first like define what we actually want to do here, and what is the difference between summarization and compression. And compression can be lossy um, or lossless compression. What you need from a summary is very different. So if you look at the standard use cases, some of the most low hanging fruit for summarization is summarizing research papers. But research papers are already so, they already contain implicit TLDRs. So there are many documents and many domains where the documents have implicit TLDRs, just like summaries or even the abstracts of summaries. Research papers and the abstract of research papers. And you have like a lot of summarization models that try to summarize abstracts, like take an abstract of a research paper and then summarize it in a single sentence, or take an entire research paper and then generate an abstract for it. But in both cases, the fact that the papers are written in a way that they contain implicit TLDRs make the whole use case deceptively simple. But if you look at other things, so for example, there's a WhatsApp group chat transcript, and it's a very long transcript, and you want it to be summarized. So you are looking for, and maybe it's just a group chat between friends. You are not looking to find out who, what what has been spoken, like a summary of every little thing that has been spoken. You are only looking for what gossip you have missed. But is a model directly going to be able to pick that up? And if you are able to fine tune it somehow, are you able to train it with that particular objective? And then let's take an even more difficult example. So we are in the financial space, and one thing that our customers told us is they would like to have like these uh, things like background memos. So let's say that they want to invest in a company, and maybe let's say that company is American Airlines. So you want to collect information from a variety of sources, and that sources can run those sources can run up to hundreds or even thousands of pages. But you need to put them all in just a 5-page report. And this is like long document summarization, but let's say the output is like, take something that is written in 1,000 pages worth of text and put the salient parts in just 2 pages or 2 to 3 pages of text. And now you have to figure out what exactly needs to be put in that the 2-pager what deserves to be put there and what doesn't deserve, and how do you determine. So it, and especially here, the data sources are different. So even if you consider that you are training, fine tuning a model, um, every company, the types of data that is disclosed or that is available is very different, and also the types of information that can be interesting is very difficult. So for example, for a pharmaceutical company, you would be interested in things like which of their, you know, candidate vaccines have entered phase 3 trials, and that information is completely irrelevant for even someone in a similar space, like maybe a healthcare insurance provider. Um, and there are so many, and there are so many different domains. The domains of interest is vastly different and changes, you know, every few companies. So you will be left to deal with. So if you think that, you know, pharmacy is an exception, it's not, because everywhere, every different company or subsector has its own nuances. So how are you going to create a summary in that case? And how are you going to, you know, get an LLM to handle all these intricacies? So we'll talk about, you know, the criteria that, let's say we are doing this with using GPT-4 few short. So few short means you have a context window of 16K. If you are using the GPT 3.5 Turbo 16K context window, or you have a context window of 8K if you are using GPT-4. But one interesting experiment that we made at our company, because we know that, and there have been research papers out recently that showed that, you know, the longer context models don't really come with a free lunch. They come at the cost of recall. Um, so one experiment I did was to put a bunch of factual information in the prompt, and start off very little, like start off with just 100 tokens worth of information, and then I ask a question about that information that it has to answer. It's a very straightforward question, and it has to answer that question. Uh, and I think the factual piece was something like Mr. Ribbons wore a yellow suit or something like that, and it had to answer a question about that. And I kept repeating the experiments by adding more and more tokens, while keeping the sentence about the yellow suit in the middle of the context. And I wanted to see, basically, I wanted to see how good the recall would be, whether if I added the, you know, context length, like if I added more and more context, at what point would it, you know, stop answering? It was an interesting experiment because, you know, after I exceeded like 4K context length, I was not getting 100% recall anymore, which means that the LLM, in this case, GPT-4 or 3.5 Turbo, were not able to always 100% of the time able to give me the answer, because it was now buried in so much other text that it would not be able to retrieve the answer from its own prompt. So that means that, you know, at least for that particular experiment, so I did a lot of generations for that. So every time I you know, increase the context by, I think, 100 tokens, and then I had like 10 generations to find out how many times out of 10 does it get the answer right for the same question. From those experiments, for me, it looked like the effective kind of context length size is like around 4K, or even less than that, kind of 3K. Once you go past 3K, it actually is no longer getting the answer right 100% of the time. So out of 10 generations, maybe it only gets 9 of them right. And then it starts degrading over time. And as you increase the context length. So basically, that means that we have an effective context length of, let's say, only 3K, and now we have to satisfy this much criteria. Actually, there is number 10, and I don't remember why it left out, but it's length. But these, so there is relevance, and that is, I guess you can uh, measure it by precision. Completeness, you can measure it by recall. But then there are a few other things like specificity. And this is something that is underrated in summarization because there is such a thing as over summarization. For example, I see this in mem, um, those Twitter bots that use LLMs to summarize, and basically they try to summarize a thread, and oftentimes I see it summarizing something to the point that it's so banal and without any information content at all. It just says, "Oh, these two people were having a conversation about finance," but you are not interested in the fact that they did that. You are interested more in specifics about what happened, and so this runs contrary to the actual summarization objective on which its models are usually pre-trained plus fine-tuned on. There is also non-repetitiveness, that you don't end up repeating the same things. This gets difficult because people generally try and repeat themselves. If you are looking at like a call that you want to summarize, people generally repeat themselves, but they don't repeat verbatim. Sometimes the second time they say it, they have a little more information content. Um, and then now you have to figure out how to take the things that were said the second time but remove the things that were already mentioned, which is not a trivial task. There is also a structure, and this is not maybe not required for everybody, but our customers would like structure. They would like to have a consistent format for every summary that is generated, which means like maybe it starts off with an initial paragraph, and then it maybe contains these particular subsections. Maybe it needs sentences to be in a bulleted list, or so there all kinds of structure can be imposed. Then there is of course factuality and auditability, which goes to the truthfulness of it. And then there is the coherence, which is, so if you are writing a summary, it should read like they are a bunch of, it shouldn't read like it's just a bunch of sentences put after one another. It needs to have like a narrative that you can start off with and continue. Uh, and then finally, succinctness, which is, again, this is like the core summarization purpose. It shouldn't unnecessarily go into details. And then finally, length. You should try to have like a lot of information density. These are all slightly connected to each other, but I can, give you like um, explain how each of them differ from each other if anyone needs. Um, but basically, what we found was um, there are so many trade-offs to be balanced here. The most, you know, uh, obvious one is the precision to recall trade-off, and that is like the most traditional trade-off that people have always. But there are so many other trade-offs here. So, for example, if you impose structure, it comes at the cost of completeness. If you try to impose succinctness, it comes at the cost of actuality. So there are so many. So just optimizing for each of them, you are going to bring about a degradation in some other thing. And some of these are just properties of LLMs themselves. Um, so in this case, remember that I am, and maybe I haven't mentioned it yet, but I wouldn't necessarily exclude things where you are using a retrieval model beforehand to get something that is a lot more relevant. So the context need not include the entire document. It can just include the output from a retrieval model, which first goes through your document and excludes all the irrelevant information, and then just puts only the relevant information. And you even after doing that, and then if you are just using GPT-4 for summarization, you will have all these different concerns. So we're talking about hallucinations, and I see like a lot of people claim hallucinations are a done deal, or they claim, hey, we have some cool prompting technique that prevents hallucinations, and that is not true at all. You can't prompt your way out of hallucinations, um, and sometimes the hallucinations are so subtle that you won't realize it has hallucinated. So, for example, I remember we were testing on a particular document, and it said Mr. Nadella. Well, Nadella is like the CEO of Microsoft, and it referred to Mr. Nadella all through the document. And then a good nice summary was produced, and in the summary, it said Mr. Nadella everywhere, but somewhere it just said Satya Nadella, even though the word Satya was never there in the original document. And you would not notice it during manual verification because you would, not necessarily think of looking at whether the word Satya was ever there, because that is not the most, important thing when you are manually verifying something, right? So, but however, there was, something that was not provided in the context that ended up being generated, and those things happen quite often. Uh, One thing to note is, so when does a hallucination happen? It usually happens when you force an LLM to fill in the blanks inadvertently. When it doesn't have the information that it needs from you, it's forced to fill in the own blanks. And a good, prompting strategy is to always work from there. Does the LLM have all the info possible? And info in this sense doesn't mean like just the information that it needs to provide an answer, but it also means the specificity or like the clearness of the instructions themselves that you put in. So, but even then, even if you are like 100% careful with that, you can't, you can't get rid of hallucinations completely. So one thing, for example, if you optimize for structure, um, it, the generation tries to force itself into adhering to a certain structure, and then it gets boxed into a place where it can do nothing but hallucinate. So that is like one of the, so that's when, you optimize for structure, you lose factuality. You can optimize for, I guess, uh, the non-repetitiveness, but uh, lose completeness in the meanwhile, and so on. So there's so many of these dimensions. So going back then to how we solved it. We initially, when we started this project, we were thinking, okay, 50% of the task, as in the capabilities needed to solve this problem, 50% of them would be handled by our own custom models, and 50% by GPT-4. I mean, approximately. So that was what I was thinking. I was thinking like the initial stages of this pipeline would be handled by the smaller models, and the larger models, in this case GPT-4, would do the last 50%. But when we went into production, we actually went with 90% smaller models, 10% GPT-4. In fact, GPT-4, all that it is doing right now is taking a list of sentences that are already categorized. So that means they already have the structure. And then all it does is convert it into bullet form, as in a bulleted list, rather than a sentence that is already present in a financial document. So remember, like the use case here is generating the summaries of that provide background for particular companies like American Airlines. So GPT-4 is excellent as a wordsmith. So that means that it's really good at linguistically altering a initial sentence that was maybe written in legalese jargon, like financial jargon, etc., turning it into a slightly more readable, and in this case, like a bulleted form. So like a bulleted form sentence will be a little more succinct, etc. So that's where GPT-4 is helping us, because it's not able to help in balancing these trade-offs at all. Like you can't prompt your way out of it. And how do we know that? We know that because there are a lot of companies, ever since GPT-4 came out, there are a lot of fintech companies out there that is trying to do one of three things. They're trying to do a QA or a chatbot over, things like SEC filings or just general financial documents, you know. So the QA assistant slash chatbot paradigm, or the summarization paradigm, summarizing an annual report of the company, summarizing a quarterly report. And there are tons of them on the market right now. Some of them come from the bigger companies, like, there are like established players in the financial industry. Some of them are startups that, recently got, I guess, millions of dollars to work on this task. And then some of these are, in fact, like the big LLM players themselves, who, if you have seen, many of these LLM companies have got into partnerships with like McKinsey and, some of these bigger companies, and they are also working on like these domain specific use cases with them. But what we have noticed is none of them are useful enough for customers to actually make big purchases yet. So when we went out into the market and asked for feedback, none of them were, hey, that is just atrocious. In fact, many people lost their trust because of the factuality and auditability concerns. So finance has a very, very high degree of, very high threshold of trust. So one nice anecdote is that, when we are speaking to one of our customers, they were talking about a factuality mistake, and this was not a hallucination. It's like pre-GPT-4. They were talking about a factuality mistake by one of the tools in the space that happened 3 years ago, and it was just one mistake. But they keep talking about it even to this day because it was such a big deal. So you can't have any hallucination whatsoever, and even when you have a hallucination, you need to box it in such a way that it's just something that is not too consequential, like Satya Nadella, rather than something that can be materially problematic. But anyway, all of these companies like failed, and they failed because they put too much trust into GPT-4. And as I said, you can build your all kinds of posh retrieval models. Uh, you can you can have anything going up there, but the final summary model is what determines like how you balance these criteria. And with GPT-4, again, as we said, it's very, very difficult to get all these together. So the other thing is the domain specific knowledge that is required. And again, you can't prompt your way through providing your model with domain knowledge. So GPT-4 I noticed some time ago, doesn't understand the difference between business segments, or it doesn't um, understand the concept of a business segment, and it conflates them with the user segment. So business segment is something like AWS is a business segment for Amazon, and user segment is something like, retired people are a user segment, Gen Z is a user segment, and it somehow doesn't understand, you know, it conflates every once in a while, those two concepts. And you can say, okay, so I just put those instructions in the prompt, right? But you can't prompt your way through providing your model with domain knowledge. Again, the prompt is just 4K. The effective prompt size is, it's just 3 to 4K. And you have hundreds, if not thousands, of financial concepts. In fact, you want it to be a equivalent of a CPA, which it obviously is not. And sometimes the problem isn't even lack of knowledge, but it's with reasoning limitations. So you don't want to be in a position where you are trying to generate a summary, but again, you are forcing the model because you gave the instructions in a particular way that it induces the model to try to do some reasoning on it. So during our initial experiments, we found that in certain cases, the model was saying a subsidiary of that company was a competitor of that company, which of course is not the case, because we can use common sense reasoning to note that, like, if this particular company is your subsidiary, it's not your competitor, and because that's common sense. But GPT-4 fails in a common sense test like that. And of course, you can say, okay, actually, when I say fails, I don't mean it fails all the time. I mean it fails like 2 out of 10 times, maybe 5 out of 10 times, like for different concepts. So so that's one reason why you have to take, like, so there was this recent paper, I think it came out saying that GPT-4 can't reason, which I think was a terrible paper. And it's found so how polarized the community is, because people started retweeting it without even reading the paper, saying, hey, I told you GPT-4 can't reason. And then someone posted like a counterpoint, and then all the people who were against, uh, you know who were like more bullish on LLMs were retweeting that. And I don't know if they actually, anyone, how many of them actually bothered to go through the paper and read stuff. But overall, while evaluating LLMs, one thing to note, I guess, is, it doesn't matter if it gets it wrong, like maybe 1 out of 10 times rather than all the times. So it depends on your end user application, what is like the trust factor that you want there. And if there is a case where, this needs common sense reasoning to know that a subsidiary can't be a competitor. And if GPT-4 gets it right some of the time, but not all of the time, it's just equivalent to not getting it at all, because you need that level of trust. Again, in the end, it's like, again, don't put your LLM in a position where it has to solve a task it doesn't know how to. And this is where you need to, like, again, when people call prompt engineering, or a dark art, it's not really as there is still things that people don't understand, but overall it goes back to this. And when you have these extremely complex financial documents, it's impossible to adhere to this. You will have to, because text is underspecified. Text doesn't contain everything that you need to know, in order to solve a task, right? So a lot of text assumes that this is understood. This is taken for granted. And when it makes that assumption, it's correct for humans, because humans have a lot of outside context. We have grounding to the real world, and we can make certain inferences that are not in the text. So, for example, in a financial document, we don't need to be told that a subsidiary is not our competitor, because you know everyone knows that. But an LLM doesn't have that same level of grounding. It doesn't have that same level of intelligence, and that's when it starts getting bad. Therefore, what we ended up doing in the end, and now we have this model up in production. In fact, I mean, I am of course biased, but um, without, but it's really something that we have seen. It's the summaries that we put out in production, where we use GPT-4 only for the final 10%, are vastly superior to the ones that are out there, and that has been corroborated by our customers as well. So it's still not, so we are still in, a beta phase and everything, but it still needs improvement, etc. But just moving away from GPT-4 and using our putting more trust into our smaller models helped us improve our quality by a whole lot. In fact, like if on our website, if you look at the page for this particular product, there is a quote by a customer that says better than an intern. And this is basically what it is doing, right? This is not augmenting humans. It's actually replacing a human who usually has to spend a whole lot of time manually going through a lot of documents, manually, or using, existing software or even LM tools to put up a document that is basically a report or a memo about a company that you want to invest in. But this is like completely automating that process and completely doing what a human would do, and at scale, because a human, I don't know, they would take several hours or days to research a particular company, but this one would do 10,000 companies in maybe a day, or it's just limited by GPT-4's, I think, 40,000 tokens per minute per organization. Like that's the limiting factor.